Bismillahirrahmanirrahim. Dear students, now today I will discuss about history and development. As I told you before that many scientists, as soon as they were realizing um, organic compounds, they were classifying those compounds on their similar or dissimilar properties. Boyle was quite successful in defining the definition of acid. He reported that acids have sour taste, they are corrosive in nature, and they have ability to change blue litmus to red. And when these acids are combined with bases, they lose their acidic character. And you can easily understand that why this happens, because when an acid and base react, they form water and salt. And acid sorry salt and water, they both are not acidic in nature. So if they take blue litmus, it will not be changed into red, and if they take red litmus, it will remain unchanged. So again, while defined base that bases are slippery in nature. Actually, alkalis are those bases which are water soluble. All bases are not water soluble, but those which are soluble in water are alkalis. So they have ability to change red litmus into blue, and when these are combined with acids, they lose their property of slipperiness and turning red into blue. Same here, that these are forming salt and water. So many examples are given according to this scientist. Then came Arrhenius. He gave the idea that in water or in aqueous solution, like hydrochloric acid is dissociated into H positive and chloride. And he was quite confident that uh, the concentration of H positive ion is increased in the water. But in practice, the positively charged protons, these protons, they exist as hydronium ion in water, because as I told you before, the solvation of water. Okay. Then he about bases, he gave the concept that concentration of hydroxyl ions is increased in water, and he gave this sodium hydroxide is dissociated into sodium plus ion cation or hydroxyl anion. He simply, we can define that acid base reactions are Arrhenius acid plus Arrhenius base, that is water and salts are formed when an acid and base react. And actually the H positive and OH negative, they are neutralizing each other. So finally we can define that Arrhenius acid reacts with Arrhenius base, salt and water is produced, and these because H positive and OH negative, they are cancelling each other or neutralizing each other. So these are also known as neutralization reactions. Uh, as it was developing, so there was limitations because there are so many acids and bases which uh, don't dissociate in water, and other solvents are used to uh, have reactions like, or those compounds to behave as an acid or as a base. But water is not the solvent, other solvents are used. Similar reactions can also occur in non-aqueous solvents. So, and there are many other examples that solvent or liquid phase was not required. These molecules were reacting in gas phase. So there, uh, these scientists Bronsted and Lowry in different areas of the world, they put up uh, with this theory. So if we summarize that H positive in water is an acid, OH negative in water is a base, and according to Bronsted and Lowry, anything which is proton donor is a is an acid, and which is proton acceptor is a base. And these limitations were actually solved by uh, later on by Bronsted and Lowry and Lewis. Bronsted, Lowry, and Lewis. Now, disadvantages of Arrhenius theory that water is not always the solvent. It doesn't explain why some compounds in which hydrogen has an oxidation number of +1 dissolve in water to give acidic solutions, while others, such as methane, do not. Why dissociated? Why some have dissociation power and some don't have? Only compounds that contain the hydroxyl anion can be classified as Arrhenius bases. And if pyridine, it is a base, ammonia, it is a base. Both of these, pyridine and ammonia, they don't have hydroxyl ion in these, but these act as bases. So how we could explain it on the basis of Arrhenius concept, like sodium bicarbonate. So Bronsted, Lowry was these two scientists were not able to explain fully these limitations or advantages, but they were very successful to explain very vast knowledge about acids and bases. So according to Bronsted or Lowry, base is any species that is capable of accepting a proton. Base is proton acceptor, and anything which is losing, removing, donating proton will be definitely a is an acid. Water has dual characteristic. It is neither a pure base nor a pure acid, because if strong acid is present, it will behave like a base, and if base is strong, it will behave as an acid. So strong acids and base, they have tendency to be ionized completely in water or any other solvents, while weak acids, uh, they are partially ionized in water. From here we can give conjugate base, or we can learn the concept of conjugate acid or conjugate base. The conjugate base of a Bronsted Lowry acid is the species formed after removal of proton, while conjugate acid is the species formed after the after accepting proton. If we summarize, uh, Bronsted Lowry base is any species that is capable of accepting proton acceptor, then it is Bronsted Lowry base, and when it is donating proton, it is an acid. Then he defined that strong acids are completely ionized in water, and conjugate base is formed when proton is removed. After removal of proton, conjugate base will be formed at the right hand side of the arrow. And if acid is on left hand side, after the removal of proton, conjugate base is formed, and when base is present, it is protonated base. After accepting proton on right hand side will be in the form of protonated base. This is conjugate acid. If we take example of water, water after giving proton, hydroxyl is hydroxyl on right hand side is conjugate base of water, because on left hand side water is um, water is used as an acid. Water is behaving like an acid. But if water is protonated, it becomes hydronium ion on right hand side. So this is conjugate acid of base proton. Water, if it is behaving like an acid, it will give off proton, it will become hydroxyl anion. This is conjugate base of acid water. Water, when it is protonated, it becomes hydronium ion on right hand side. So this is conjugate acid of base water. So this is amphoteric behavior of water. Now the electronegativity of oxygen is 3.44, and electronegativity of hydrogen is 2.2. So this bond is polar, and the electrons in the hydroxyl bonds, they are not shared equally, because oxygen has tendency to attract electron towards itself. So you are seeing arrow towards oxygen, it has partially negative charge. It is showing, it is displayed in this structure that the flow of electrons is towards oxygen. So that is why it is partially negative. And both these protons, they are sigma positive, showing that these are partially positive. And as a result, this water molecule becomes polar. And when they dissociate to form ions, H will be shown as delta positive and OH negative with negative charge. Water is equilibrium constant. It is dissociated into H positive and hydroxyl anions, proton and hydroxyl anions in water. And if we see the reaction, we can say that H positive and hydroxyl, when they are combined, they form water. So water is in equilibrium. Water, you are seeing this backward and forward reaction. So I have also told you about solvation. I am again summarizing it, that when we take the example of sodium hydroxide base, sodium anion, once sodium hydroxide is dissociated completely in water, what happens? The water molecules, the negative terminal of oxygen solvates the negative terminal, the lone pair negative means negative, is solvating, caging यानी कि पिंजरा बना लेना from negative side, because sodium is positive, so affinity of negative and positive. What happens that the negative charge, the lone pairs, they are solvating, they are caging the positive charge, so it is stabilized. It will never ever think to combine again with hydroxyl. So if they could not be combined with hydroxyl anion, it means no more sodium hydroxide in the medium. And what happens with hydroxyl anion? The protons, which are positive in nature, they are partially positive, they are caging, they are solvating hydroxyl anion. So this negative charge, it is not easy for it to recombine with sodium to form sodium hydroxide. If sodium hydroxide is not formed again, it means they are living independently, uh, they are not combining with each other. Both sodium plus and hydroxyl negative, they are living as such with their positive and negative charges. And I have told you that anything which is charged doesn't like to exist fully charged or fully negative. So what is making them less positive or less negative? Water molecules. But on sodium, negative terminal is stabilizing that cation, and for anion hydroxyl, positive terminal of water is stabilizing or solvating negative charge. So and when we see the net reaction, that sodium hydroxide or sodium hydroxide and water, they were combined, sodium salt was formed and water was formed. And in the water, because sodium chloride was dissociated, same solvation, water positive terminal is solvating chloride, so on that side blue with blue, chloride, positive water, hydronium ion, the best explanation of water, hydronium ion, and hydroxyl is solvating sodium. So when these are combined, salt and water is formed, two molecules of water. And net, if you see the net reaction, because positive side same cation and anion, they are cancelled with each other. And what happened? Hydronium plus hydroxyl ion, water is formed. So these sodium cation and chloride salt on our right hand side and left hand side are actually spectator ions. So now coming towards the third important theory of acid base put up by Lewis. Simply, any compound which is electron acceptor is an acid, and any compound which has ability to donate electron pair is a base. So we can also name as Lewis adduct, or coordinate bond is formed if you are given that make an Lewis adduct. You should not be confused. If you are told to make where coordinate covalent bond is formed, you can confidently draw the structure. So if we summarize, or if we elaborate what is going on actually by electron acceptor and donor. There is lone pair on ammonia, and if there is boron has vacant orbital. It has tendency to accept electrons. So BF3, um, BCl3 or aluminum chloride, they have vacant p orbitals. AlCl3, if it can form a duct or coordinate bond with ammonia. Ammonia has lone pair. And other cations like iron, magnesium, lithium, these ligands complexes are formed, and these are very much good examples of Lewis acid base. And other elements like antimony, arsenic and phosphorus, and homo lumo hasab, hsab. In some books you will be given shab, shab, soft acids and soft bases, hard acids and hard bases. In next inshallah lecture I will tell you about hasab or shab theory, what type of this these definitions. Okay, pyridine, as I told you before, pyridine, it is aromatic heterocyclic compound. It has lone pair. It can be protonated. It can accept proton. So this is actually uh, basic in nature, uh, because it is giving electrons. Electron donor, that is why to proton it is giving electron to make a bond, and as a result it becomes positive. Anything which is positive, em, pyridinium cation, hydronium ium positive, pyridinium positive, carbonium ium positive. Anything which ends with ium, mostly not don't confuse with magnesium, calcium, those are elements, but any compound which ends with ium, ammonium, NH4 positive, ammonium compound, it is positive em, ium, carbonium, hydronium, pyridinium, and carbonium, pyridinium, hydronium, like that, and pyridinium. So you can see these how hydronium ion is formed. Lone pair donor, water is lone pair donor, electron pair donor, electron, lone pair donor, it will act as a base. Proton is this electron pair acceptor. Electron pair acceptor, an acid. Electron pair donor will behave as a base. So this adduct is formed, hydronium ion, then ammonia. Lone pair donor will be a base. This proton is accepting, it has vacant s orbital. So lone pair is given to make a bond and is forming 4 bonds. As a result, lone pairs are sacrificed by nitrogen alone to make a bond. 2 electrons are required and both electrons are given by nitrogen. Proton has nothing. So both electrons are given by nitrogen, bond was formed. But if one electron was given by hydrogen, one electron was given by nitrogen, nothing happened, it was neutral. But when both electrons were given by nitrogen, bond was formed, between nitrogen and hydrogen, so it became positive because both electrons are given by, it is electron deficient now, and to show deficiency of electron, positive charge is present on it. And there are other examples given. Silver is metal, electropositive in nature, vacant orbital, it can accommodate electron. Electron is given by ammonia. Complex is formed. This adduct, this is very famous reaction. So ammonia is behaving because it is giving electron pair donor base, Lewis base, and silver having vacant orbital is behaving as electron pair acceptor, and as a result this adduct is formed. Here ammonia acts as a Lewis base and the silver ion act as an Lewis acid, as an acid. Each nitrogen atom donates an electron pair to silver, resulting in two separate coordinate covalent bonds. Two coordinate covalent bonds are formed. Two ammonia molecules are utilized, and this is important reaction in many uh, uh, organic compound identification as well. So this is best example showing illustrating Lewis acid base concept. Now another example, boron is also electron deficient. So when any halogen halide, it reacts with the boron compound. For example, here we are seeing BF3, boron trifluoride. When it reacts with again fluoride, fluoride has a whole negative charge, so bond is formed and both electrons are sacrificed by fluoride. So negative charge on boron because it is not uh, giving any electron to make a bond. Both electrons are given by fluoride and negative charge is present on this adduct. So fluoride is giving um, electron pair. So this is Lewis base and BF3 is accepting electron. So it is an acid. So BF4 negative. So I hope it is easy for you to understand. And see you for your next lecture inshallah. Assalamu alaikum.